Hello, Algebra 2ers. Today we're going to be starting a new unit. It's all about solving systems. So what you're going to need is a pen or pencil, your composition notebook, and then a foldable with all of your notes in it. In your first flap in your foldable, it's titled What is a System? A Solution. That should be on the bottom and the top of your little flap. Inside, you should write down what's in red, those two definitions. A system is a collection of two or more equations with the same unknown variables. So two equations like we have in the example below, where we have an x in both equations and a y variable in both equations. And then the solution to that system is the numerical value for each variable, or the number for x and the number for y, that will satisfy or make those equation statements true in the system. So I'll show you what I mean by this example. So go follow along with me and write down what I write down for this little example. So we're asked, is the point -2, 3 a solution in the system of equations? Well, we always know that ordered pairs come as x, y. So they're telling me that x is equal to -2 and y is equal to 3. So what we need to do is plug those two values into both equations and see if those statements are true. So let's plug in -2 in for x plus y, which is 3, is equal to 1. So I plugged in a -2 and 3 in for y. -2 plus 3 is 1, which is equal to 1. So the statement is saying 1 is equal to 1, and we know that that is true. So it checks out. Okay, let's plug in -2 for x in the second equation and 3 in for y in the second equation. So we have 2 times the -2 minus 3 is equal to 8. 2 times the -2 is 4 minus 3. -4 minus 3 is a -7 equal to 8. Well, -7 is not equal to 8, so that statement is actually false, which means that this is not a solution, right? The point has to be the point would have to make a statement true for both equations, but we have one equation where the statement is false when we plug in that point. So the yes or no answer is the point, yes or no, -2, 3, a solution to the system. Our answer would be no, it's not, because of this false statement right here when we plugged in -2 and 3. So there are three possible solutions to a system. So if we open our graphing method tab in our foldable notes, on the top, it asks how many solutions can a system have, or will a system have? There's three possibilities. The leftmost side says that we could have one solution where two lines intersect. So on your little graph, you want to draw two lines intersecting at some point, and they could be like this, they could be like that. It doesn't really matter where they're intersecting, okay? Just two lines that are intersecting, and then that one solution is always going to be x comma y, or an x value and a y value. If we move to the middle graph, you can see that we have two lines that are parallel. So since these lines aren't intersecting, that means that we would have no solutions. So make sure that you draw on your middle graph two parallel lines and write no solution. And then on the very right graph, it's just one line, but it says that we have infinitely many solutions. So what's going on there? So say we have an equation, y is equal to x plus 5 or something, right? And we graph that line. And then we're given another equation, y is equal to x plus 5. Well, that's the same equation, but now we're just going to graph it right on top of it. So if two lines are lying on top of each other because they're technically the same line, just graphed twice, what's happening is that they're intersecting at every single little point along both of those lines, which means that they have infinite solutions. So when you draw on your right graph, just show one line and then write infinitely many solutions. Okay, let's try one example with the graphing method. Remember from the last unit, we talked about three different ways to graph. So we can graph using y is equal to mx plus b. We can graph using intercepts. And we can graph using the translated form, which is y is equal to m times x minus h, all plus k. So if we look at our example, we have x plus y is equal to 1 and 2x minus y is equal to 8. So we need to ask ourselves which method out of the three that I wrote down are the best ways to solve? Well, is it already in the form y is equal to mx plus b? Nope, not for either of them. And is it in the translated form? Is there some x minus h plus k with parentheses? Nope. So that means that I'm probably going to want to use intercepts, which is also known as the cover-up method. So what that means is if we plug in 0 for x and solve for y, and then plug in 0 for y and solve for x, that's going to get us two intercepts that we can put on our graph. So for this first equation, I'll do it in red. If we plug in 0 for x plus y is equal to 1, then we know that y is equal to 1. And if we plug in 0 for y, x plus 0 is equal to 1, then we know x is also equal to 1. So these 2 points are intercepts on my y-axis and on my x-axis. So x is equal to 1, I'm plotting that point, and then y is equal to 1, which is up here. Sorry about that. So now I just have to keep making dots with that slope. Down one to the right one, down one to the right one. Keep going. And you can keep going on the whole graph if you really want to. Draw your line. And let's try the second one. And I'll do that one in purple. So if I set 0 equal for x, so 2 times 0 minus y is equal to 8, I get 0 minus y is equal to 8. Negative y is equal to 8, divide by negative 1, divide by negative 1, y is a negative 8. So I'm plotting that point here. And then if I plug 0 in for y, I get 2x minus 0 is equal to 8, or 2x is equal to 8. Divide both sides by 2, and x is 4. So we're going to plot our point there. So if I go up 8 and to the right 4, my slope is essentially 2. So if I go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, this is where my 2 points are, sorry, 2 lines are intersecting. They're intersecting at this point, and that point is 3, negative 2. So we had 2 lines that intersected, which means that we have one solution, and whenever we get one solution, we want to give that solution as an ordered pair. So my solution is 3, negative 2. I want to thank you all for taking such good notes, and I shall see you soon.